Dear Professor, today I'm going to present our team's senior design project, the identification of the painting by using machine learning. Our team members are Xinran Shen, Zhan Shu, and Xiaohan Li. So let's start talking about our project. Firstly, I will give a brief introduction of our senior design project. As machine learning algorithms have advanced over the last decade, there has been an increased interest in applying them to a variety of computer vision problems. We have identified identification as a relevant and challenging activity that could benefit from machine learning algorithms. However, research on automated art identification is very sparse, and only recently has been an increased interest in applying machine learning to the context of paintings. In 2008, a paper titled Image Processing for Artists' Identification, which was published on Signal Processing magazine from IEEE, written by C.R. Johnson and J.Z. Wang. This paper presented an algorithm for verifying the authenticity of a particular painting by considering very high resolution images of Van Gogh's paintings. In our project, we want to examine how machine learning can be applied to the more general problem of identifying an artist's painting. After doing some research on the internet, our team finds that some impressionism or post-impressionism painters have the very similar painting styles, such as Cézanne, Monet, and Van Gogh. Our goal is trying to identify these similar genres paintings work by machine learning. So, as for the voice of customer, we opened an online survey on WeChat for a week and gathered some information from students and teachers in various majors. From the result of our survey, we find four main advantages for our project. So let's talk about them one by one. Firstly, it will provide a similar way to find the similarities and differences between different paintings, just as what I mentioned before. Secondly, it gives a portable and this program can be operated easily. It will provide a high accuracy and faster identification rate, which we will explain it in detail later. Finally, our project will tell the most typical features to guide and teach people, which will be a main application for our project. As for our applications, we believe that this can have interesting applications for art historians and also the scientists. The program will help them to understanding how far different artists' works are similar, what some objective characteristics of an artist's painting are, and how machine learning can be used to authenticate paintings. For example, one particular application is that our program can be used as a teaching tool for some fine art teachers to provide how similar two different paintings works are. So, as for the constraints, uh, the most constraint for our project is the accuracy. The accuracy may reduce in identifying some painters whose genres are quite similar, such as Renoir and Monet.
Our primary objective is to identify the author of the paintings, and this is also our main function. And the main constraint of the project is the accuracy of the identification. The performance of recent research on automated art identification is not very well. We want our classification rate reached 80%. Our initial choice for the features was wavelet transform, but we cannot discover any useful features. We therefore then studied the pixel of the images and the color histograms and more advanced features such as HOG 2x2, SSIM, dense SIFTs, and we will use a SVM as a classifier to classify our paintings. We want to develop an application that user can use the camera of the smartphone to take the photo of the paintings, and our program will analyze this data and identify the author of the paintings. We want it easy to use. In particular, our data, the image of the painting, was downloaded from the internet, so their size, their resolution, and the format are diverse. So the first thing we will to do is to convert these images into same format. And we will normalize each image to hundreds by hundred pixels when using the pixel features, and shrink the color space to 18-bit colors to reduce the number of features when using the color histograms. We think that different artists may have different preference of colors, so we think it could be a way to identify painters by analyzing the usage of colors of paintings. Color histograms are flexible constructs that can be built from images in various color space. A histogram of an image is produced first by discretization of the colors in the image into a number of bins, and counting the number of image pixels in each bins. And we also think the way artists depict the objects may be unique, so they have their unique styles, and the appearance and shape of the object of the same author may share some similarities, and the appearance and shape of local objects can be well described by a orientation gradient of the edge density distribution. The histogram of oriented gradient (HOG) is a feature descriptor used in computer vision and image processing for the purpose of object detection. Since HOG is a local feature, we should divide our images into blocks and then calculate the orientation gradient of each block using kernels. We will apply rectangular 2x2 HOG block structures to analyze the features. The gradient histogram in the range of 0 to 360 degrees, which will be divided by 45 degrees, without a total of 8 columns, or divided by 10 degrees, without a total of 36 columns. And the other algorithm is the Scale Invariant Feature Transform (SIFT). It is an algorithm to detect and describe local features in images. SIFT is very similar to HOG, but SIFT is calculated by multiple scale space. We first construct the differential of Gaussian scale space by Gaussian convolution. And then we will create an image primary. For an image, we first convert it to different scales. Each scale can have any dimension corresponding feature points. The first subscale adds the original size, and the next scale is downsampled to 1/2 of original size, and constituting a next subscale. We will do the differential of Gaussian detection scale space extreme, which is comparing each sample point to all its neighboring points to find minimum or maximum points, and the points we find is considered to be a feature point image at that scale.
Next is our design process overview. The first step is data collection, which is collecting different paintings from different artists and convert them to digital images. The second step is feature selection. As we mentioned before, the basic features are pixels of images and the color histograms. Also, we have advanced features as dense SIFT and HOG 2x2. The next step is classification. We use SVM to classify two-class artists or multiple class of artists. The final steps are figuring out the similarity within the features and the feature performance, which we are going to do next semester. So here's our task table for the next phase of our project. First, we need to apply 3 kinds of algorithms to collect paintings. We expect each of them will last 14 days, from January to February. After this, we will do the comparison between these kinds of features and see how they perform, whether they are proper method corresponding to the artists. This will happen at the end of February and the beginning of the March. Next, we like to develop an application on mobile phones using our program, and this will last most time of the month of March. Finally, during the end of March and the beginning of April, we will accomplish our expo poster and write our final report. So finally, is our issues of concern. The first thing we concern about is our quality of collected data. As we know, there are several paintings that are very similar to each other, but by different painters, and we are not very sure that our algorithm could find features that could easily tell the difference. So data qualify is important. Next is the accuracy of identification, also which is also our first priority. We want to make sure it is stabilized at a very high level, and that can avoid the user's troubles as much as possible. The last one is our comparison of different algorithms. Since we use different algorithms, we need to find the best one that can represent most of the correct identifications and the most applicable one. Since our work, most of our work are based on the programming level, so the bill of our project is 0 by now. That's all. Thanks for your listening.